Okay. Thanks for being with us. Tonight we're going to talk about an extremely interesting and maybe contentious issue, which is how the human environment and the rest of the environment interacted in the old Maya world, not only in the old Maya world, even today, and what that means for sustainability. Are there lessons that we can learn? We maybe would like to see the past as a teacher. Our cultures have always changed and transformed, and sometimes they've disappeared. And history and the environment shaped culture and vice versa. Our cultures, our societies, our activities also do things to the environment. And the Maya have been around for thousands of years doing very, very interesting things. How they did it, can modern science learn anything from them? We're going to have an excellent panel, extremely interesting, with people very knowledgeable about their topics. First, we have Anabel Ford, that works at the University of California at Santa Barbara. She's here pointing to a very mysterious citadel that she discovered. Her interests are in agroecology, environmental anthropology, and economic botany, and she does research with traditional Maya knowledge, not only from an archaeological perspective, but also working with people right now in terms of how their culture and their knowledge allows them to survive and to thrive in their environment. David Lentz, who's here, ensuring that that tree does not fall on his head. He's a paleobotanist and a paleoecologist with an interest on how the human use of plants, domesticated and wild, have changed through time. He's at the University of Cincinnati in Ohio. And he's investigating how agroforestry and water use activities in Tikal took place. Then we have Javier Caballero, who's there sustaining something or preventing something from spilling. He's an ethnoecologist interested in sustainability and traditional resource management. He has published in many topics related to how how traditional knowledges are structured, how they are expressed, and how they are assembled, how different cultures structure what their knowledge about the environments. And he works in many parts of Mexico, but certainly here in the Yucatan. Last but not least, we have Gerald Islebe from the Departamento de Conservación de Ecosur in Mexico. He's a paleoecologist, community ecologist, and he's interested in biogeography and conservation and climate change. He's interested in the effects of large-scale changes like climate in the ecophysiology and the structure of ecosystems. He works in the Yucatan Peninsula. At this point, I am going to ask one of our colleagues to come to explain, because we would like you to participate in a way which is more than asking questions at the end. We want you to answer questions right now, and I am going to ask.
Okay, so we are going to do something that we've never done before, and that is have you participate through a live poll system. And what that means is that we'll need you to either have access to the internet or to G4, G3 network, or just to a telephone. And the way we'll do it is like this. So we're going to work with the concept of resilience, and that the more diversity we have, the more likely the system won't crash. And what we need is that our internet system doesn't crash. And what it seems to be, if you noticed, the ATBC network appeared and disappeared, and then there were all sorts of internet options available to you. It's because ATBC1 and ATBC2 network could not handle the load, And so we'd like you to access the voting system through various options. One of them is your cell phone through local SMS to a number we'll provide in a few seconds, to your own 3G or 4G system. You can now also obtain internet through the Fiesta Rewards with vacaciones as your password, even though you're not on vacation. And the regular Wi-Fi ATBC 2017 with no password now is also available to you. We hope that you will use any one of these systems, but please don't overload any one of them. So that's the challenge that we have. And what will happen is at some point during the panel, a question will come up. If we can have an example of the question. Yes, it's coming up. And there will be oftentimes, the question will require a multitude of option of answers, and you will, such as, the question might be something like, and we'll try a little exercise here to see if this works. No? My experience in the ATBC 27 so far has been fantastic or great. And you can vote totally agree, somewhat agree, or disagree. And so you have the option to go to that link up there, polev.com/ATBC2017, or to send an SMS message to the number up there. Whoa, 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 really? Okay, this is great. It's working. Oh, we're cheating. So please try it. Just take a few moments to try this because it's extremely important that we get it right for the real questions. All right. And so we will give it a time limit so that it can't go on throughout the... And because there'll be two questions, what you'll need to do is, after you've responded, the way to access the next question once it comes up is to reload the browser or to send another message. So, okay, we're doing well. We're doing well. Somewhat agree. Okay, we're going to have to work on those disagree and somewhat agree. Great. Okay. And so now we'll start with the real question. So stop voting, everybody, and we'll go with the first real question of the topic of today.
Nos están poniendo la primera pregunta, ¿verdad? We're going to allocate about 5 minutes to this answering of questions. This is the question. Are we getting answers? Oh, yeah. I am going to give you another 30 seconds because this thing is mostly static already. Okay, can we have the second question? Here's the question on the top. One minute to answer. Tú eres el primero, ¿verdad? Tú, número uno. Five more seconds, although this is still changing a lot. Time. Okay, thank you. We're going to do something with this. Don't think it's just like a idle exercise. I'm going to ask Gerald I'm going to give him the floor for 8 minutes. He's going to give us this.
Okay, first of all, thanks for having me here for this meeting. I am still thinking myself for which question to vote. So meanwhile, I hope I can influence some voting with my presentation, as well as my colleagues from here from the session. So I'm going to talk about paleoecology and paleoclimatology of the Maya forest in 8 minutes. In the morning, we heard some stories about the Yucatan Peninsula in the late Pleistocene. The Holocene, the last 10, 12,000 years, depending on how you count it, has very small variations in temperature and precipitation, but it's very important for the development of the humankind. So what we are working is on vegetation changes related to climatic drivers and environmental change based on pollen and geochemistry and somewhat on isotopes. The Yucatan Peninsula, where the Maya forest is a very diverse area. We heard it in also this morning. There are different vegetation types. It looks all green, but we have high forest, low forest, intermediate forest, upland forest. So it's all a very complex and biodiverse ecosystem. But we have also many factors who influence on this ecosystem, climatic factors, for example, wrong button, the intertropical convergence zone, which is responsible for the rainy and dry season, with the ITC set during the rainy season in this position, and in the dry season in a more southern position over South America. The last couple of years, 2015, we had a very strong El Nino effect, which caused a strong or a relative longer dry season in the Yucatan Peninsula. And maybe you won't believe it, but one important system influencing as a climatic factor on the Yucatan Peninsula is the North Atlantic Oscillation. And during the rainy season, we have the Caribbean low-level jet, which brings a lot of humidity to the eastern coast of the Yucatan Peninsula. And that's why the eastern coast or this area has higher precipitation than, for example, the area which is bordering the Gulf of Mexico. This is a recent study we made with geochemistry, the relationship between calcium and iron, which is an indirect proxy for precipitation change for the last 7,000 years. And we have also generated this pollen data from the same core. Here we have a resolution for about 50 years for the last 7,000 years. In this geochemical record, we have a resolution from about 20 years. So what we see in these records, we have, sorry, wrong button. We have a strong recession cycle, which is an astronomical cycle, which is a global event, or at least in the pantropical area at 5.2 kiloyears. We have a strong paleo signal at 4.2, which in this record means a drop in precipitation. Then about 3,800 years, we have an increasing activity of El Niño-Sasan oscillation, which causes, again, a decrease in precipitation. So, and in the vegetation reacts in a similar way. It reacts with a lag time of about 30 to 40 years. This is due to resolution problems. But that's, and we can see that the tropical forest, which includes all pollen taxa, which are tropical trees, have this variation in percentages from about 60 from the middle Holocene to about 45–55% during the middle to early Holocene transition. Oh. Okay, Another factor which is also influencing what you was talking about is solar irradiance. 5.2, 4.2, and 2.8 are a clear example how solar irradiance influences on all ecosystems of the peninsula. This is too fast. And to show you how precipitation changed the last 2,000 years, we developed models of precipitation change based on pollen data. And there you can see from the year 0 of our era to the present, the darker it gets, the brownish, the drier it's drier. So, for example, in the year 200, it's called the pre-classic drought. We have a strong reduction in precipitation, which lasts about 100 years. Then we have an increase, still drier conditions than at present. And then in the classic period, climate is wetter until what it's called the terminal classic. It's very important to notice that the terminal classic was not as dry as a pre-classic drought. This is very important because in literature you can see about Maya archaeology and environmental relationships. This is where the Maya culture collapsed. 1 minute, okay. We also made reconstructions of Maya agriculture in our sediment course, and there we can observe that one of the main taxa is corn, sea mais. Here is a pollen. During the Maya cultural periods, there's a strong increase until the end of the pre-classic period, was climatically spoken, was not so stable as the classic period. Although we see here a drop in corn representation, and we should expect an increase. We are still working on ideas what exactly this decrease means probably a diversification of the milpa cycle. So my 8 minutes went really fast. I want you to remember climatic drivers, insolation changes, intertropical convergence zone, El Nino, Caribbean low-level jet, the North Atlantic oscillation, and hurricanes all influence on the Maya forest. And of course, we have human drivers, land use change in its different forms, and we have other natural drivers, which was too short this time to talk about, like volcanic activity. So, thank you. Please keep on voting.
So, should I use this? You can hear all right. Are the slides coming? I'm going to be talking about land use in ancient Maya. No. The first one. And how settlement patterns of the ancient Maya, I'm an archaeologist, how that can tell us a lot about how the Maya used the landscape. I'm not sure what I'm going to be looking at, are taking up sort of where Gerald went off, was looking at the last 8,000 years and how the Maya would begin to get to know the landscape and how the early occupation of the New World 12,000 years ago. ¿Qué pasó? So I don't know where my slides went, but if you can imagine the whole North and South America, ahí viene. I have a little bit of an opinion, and I call the co-creation of the Maya forest. I would vote in a different way. I almost feel certain how I would have vote. The green button. Wait. To go forward? No. Oh, here it goes. Okay, this is what I wanted to mention. So the people who arrived here, we heard a little bit about them this morning, but I don't know. I think that what Gerald talked about, what I'll be talking about, is a little bit different in terms of how we think of the early Maya area. They arrived, well, early man is something different, early humans, but that by 12,000 years, about the time of the Clovis, there's no doubt that people were all throughout the Americas. They expanded very rapidly as basically hunters and gatherers. They adapted to a changing climate from the Pleistocene Ice Age, meaning it's cold, that even here it was cool and arid, into the Holocene thermal maximum. So this is really change that's happening over 4,000 years, which in terms of adaptation is quite significant. And they established during this time long-term investments on the landscape. This picture of pollen and precipitation, the upper register is titanium, registered in the Cariaco Basin north of Venezuela, and it used as a proxy for the whole region because of the way the wet season begins coming from the Caribbean. And these data are the published data that someone like Jared Diamond or other people making assumptions about the rise and fall of the Maya would have used. Very significant. You can see the change when around 8,000 years ago it was warm and wet. We could see the temperature that Gerald put on really fits that model. This would have been the time that people in the area would have been getting used to how to understand the forest. The forest is growing in, coming in. Everybody's, every animal and plant and human is getting used to the new warm, wet conditions. And the plants of the Maya forest, while that was Ramon was the big red line, Ramon, in fact, is only one of the 20 dominant plants of the Maya forest, all of which are useful today. That's a wind-pollinated plant and has been used as an indicator of where the forest is and where it isn't. I doubt that that's a good example. Another thing is people think that that tropics overall are very poor soils, but this is really based on the very ancient soils of the Amazon, which in truth are very poor soils. The soils of the Amazon are generated from 600 million year old rocks that aren't even there anymore, nutrient poor, very leached. But the Maya forest, on the contrary, is only 65 million year old limestone, and this is a very good source for nutrient rich soils, would attract farmers or attract people to the landscape. The landscape is often viewed, this is my version redrawn because National Geographic would probably charge you for taking one. So I redrew this picture from a 1986 National Geographic. This was how they imagined the Maya landscape. And of course, if you imagine this way, you really wonder why they didn't collapse sooner. And why would they have a 1066 Normandy, which I call ecological imperialism view of the Maya forest? No vegetation. Any respectable master forest gardener who I'd speak to would say, where are the trees? How do they have water? And then, of course, it looks like Mennonites. Really, it's a dynamic landscape. It's not forest or field, it's forest and field. It's very combinations of things, open areas of annual crops turn into secondary forests that are managed, turn into closed canopy reserves, you could say, full of all the kinds of things, fruits, lumber, lanais, and things that are used in everyday life. It's a cycle. Shifting agriculture is a misnomer. Yes, if you're looking at from a European viewpoint, that you want to just look at where the fields are, but if you understand the investment, it's a full investment in that landscape that moves from an annual to a perennial. In fact, after today, I've been thinking that, talking with my colleagues, that really it's 4 years of annuals and 16 years minimum of perennials. What is the more important component of the co-creation of the Maya forest? It's the destination and the stocking of the forest. So I just give you a quick tour. Infield, a home garden, a specialist fire tender. These are not people. They arrived with ability of knowing fire and stone tools. Their use of fire is very studied. Might look like a lunar landscape to some, but you can see trees are there. The cut wood that is fast burned might even resprout. This is hastening the move into the forest component or the perennial component. They plant in the stone, not arable, but definitely cultivable, growing and reaping, and then moving in. This is a global garden. Of course, they wouldn't have had banana in the past, but they're moving into a perennial with very purposeful planting. So second growth involves planting, selecting, excluding, including, pruning. This is Chaco pruning, taking down the outer branches of the siricote. We had some siricote for lunch. And of course, perennials that are also dominant here. You can see also there are annuals in that forest. And they move into having what they call forest reserves. And I want to say that these areas forest is very resilient. This is not a forest that is not wanting to come back. If you don't use the weed whacker and don't use the lawnmower, even where they left, this is in real near Santa Elena, Cayo, where I live in Belize for my field work, and here is a ceiba growing out of an old refrigerator. So I see it as a very resilient place. Thank you.
First, I want to say thanks to Horacio Paz and the other organizers of this session, and thank you very much for inviting me to participate. It's a pleasure to be here. Here we go. This presentation focuses on ancient Maya agroforestry and agricultural approaches based on recent paleoethnobotanical and ecological data collected at Tikal, Soberon, and other Maya sites. These graphs represent Tikal population estimates. Note the dramatic population growth in the Classic period beginning around AD 250, followed several centuries later by a steep decline in the 9th century, sometimes referred to as the Maya collapse. The goal of our study was to put these events into a larger context that included agroforestry and agricultural activities. One aspect of our research at Tikal was to survey the modern forests surrounding the site. A second aspect of our research was to analyze plant remains collected from archaeological contexts at Tikal. These were the most common trees used by the ancient Maya as seen in the plant remains. This slide compares oligarchic tree species in the modern forest to trees identified from the archaeological plant remains. The presence of tree oligarchs in paleoethnobotanical contexts was significantly greater than the overall mean, indicating that the Maya were using oligarchic species, but also conserving them. This slide shows electron micrographs of archaeological wood samples. The wood on the left has parallel rays and likely came from a mature tree, while the one on the right has convergent rays and likely came from a small tree or branch. Only 3% of the ancient Tikal wood samples had convergent rays, while 90% had parallel rays, indicating that the vast majority of wood used at Tikal came from mature trees. That is to say, the Maya were managing mature forests for their timber and fuel needs. To help us understand the resource base of the classic Maya at Tikal, we created a Voronoi diagram to define the limits of their resource extraction zone. Now this outside polygon is blue-green, and it defines the external limit of the resource extraction zone of the Maya during the late Classic period. The red zone here was determined, thank you. The red zone here was determined by archaeological survey. This is where people had their houses. Some people might say this is the suburban neighborhood of Tikal. And then the area in black here was the site core. This is where Tikal had their temples and palaces. Using data collected from satellite imagery, pollen studies, stable isotope analyses, and settlement surveys, we were able to break down the resource extraction zone at Tikal into land use categories. Note that approximately 340 square kilometers remained as upland forest, and 350 square kilometers was available for agriculture. This would have been enough land to provide 40 to 50,000 people with fuel and food if a short-term fallow system was used. To help interpret observations at Tikal and other Classic period sites, the village of Soberon, which was inundated with volcanic ash in AD 660 and very well preserved, offers magnificent insights into ancient Maya land use. The village center consisted of households, as illustrated here, surrounded by dooryard gardens and orchards. Undoubtedly, the site core of Tikal, the red zone that I mentioned earlier, was utilized in much the same way. Thank you. Okay. Outside the village center were extensive fields of manioc and maize. This is the village center here, and this is where the fields were outside. The fields look like this, and they were planted with manioc and maize, and they were grown in sculpted fields with ridges and furrows to manage water flow. Maize and manioc casts clearly identify the kind of fields where they were produced. This is malanga, another abundant crop at Soberon. It's a root crop. Reservoirs at Tikal stored water for household use and or irrigation. The Perdido Reservoir was fed by canals from the Mundo Perdido Plaza in the site core. Water was released from the egress to flood fields below. Carbon isotope readings indicate that maize was grown in fields below the reservoir. A soil test pit below the Perdido Reservoir shows that around AD 500, the soil changes from bajo soil to alluvium, indicating repeated flooding for agriculture. The inscriptions reservoir at Tikal was not a reservoir at all, but was likely used as a rejollada, as illustrated here. Terraces were built in the Terminos section of Tikal. In northern Belize, several sites revealed evidence for drained fields and raised fields. In conclusion, while long fallow swidden approaches may have been adequate to meet the demands of inhabitants of sparsely populated portions of the neotropical forests, when areas became more densely populated, as during the Classic period, there was insufficient arable land to support the growth of the emerging large polities using long fallow swidden agriculture alone. Accordingly, agriculture became much more complex, and a variety of intensive crop production techniques were adopted, such as short fallow systems, terracing, irrigated fields, drained fields, ridge and furrow techniques, and cultivation of dooryard gardens. Bajo margins also became areas of significant cultivation. Woodlots likely were managed as mature forests, possibly in a technique referred to as umbrella or partial felling. All of these intensive forms of agriculture and agroforestry were employed to enhance the food, fuel, and timber supplies that supported the dramatic late Classic growth in Maya populations. This sequence of events led to dire consequences, however, especially for the Maya of the elevated interior region, where large bodies of surface water were absent. Multi-decadal droughts in the mid-9th century proved to be a catastrophic tipping point for the late Classic Maya in the EIR, because they had maximized their agricultural potential, and ultimately they were dependent on rainfall to fill their reservoirs. Moreover, recent studies elsewhere in the neotropics have shown when a major portion of a tropical forest is cleared, it ultimately will reduce the regional rainfall. It now seems likely that the agricultural practices and partial forest clearance of the ancient Maya contributed to their demise. Thank you very much.
May I have the first slide, please? Well, welcome to the present. I'm going to talk about how present Maya managed the forest as a part of agricultural practices. There are some common assumptions, such as the milpa is just an agricultural system that maybe is the only source of plant resources for subsistence. But the truth is different. The Maya obtained their plant resources in different ways. The green one? Is the green button? The green button? Okay, thank you. Oops. I don't get it. Which one? Okay, thank you. Sorry, it's technology. My point is that agriculture is only a part of a diversified system for subsistence among the present Maya. My data comes from the northern present Maya, the Yucatec Maya. And this whole system includes managing the forest, managing the secondary forest, as well as agriculture and home gardens. But it's not only simple agriculture, but it's managing plants in different degrees of domestication by humans, which includes gathering in the forest, includes also species that are ongoing management, such as tolerance, protection, promotion, and of course, cultivation. For example, this is a table that includes different useful plants for the Maya that are in different degrees of manipulation by local agricultures, including the tolerance, promotion, cultivation, occasional cultivation, and selective manage. Agricultures often select the desired phenotypes to stand when they clear a land for a new milpa. So when we see a landscape like this, highly fragmented, this is a satellite image of the same area, we can recognize three main different types of patches. Those with the milpa, those with the secondary forest, and those with the mature forest. So my graduate students and myself conducted research in that area for several years, asking us which is the main source of plant resources for local cultivators. You would think it's the maize fields, but it's not really that picture. We sampled 3 different types of patches, and we found that besides crops, you could find a number of 118 different species in the 3 types of patches, and a similar proportion of useful plants of that figure in the 3 different types of patches. There was a hypothesis by different ethnobotanists in the Brazil, in the Amazonia, and other parts of the tropics in South America, who were saying that the secondary forest is the main source of plant resources for local cultivators. So we were testing in some way that hypothesis in this area. And we were surprised by the amount of resources for different uses. For example, the milpa, the hupche, which is the secondary forest, and the monte alto, or the mature forest, they offer almost the same proportion of plant resources for local cultivators. The patches were similar between them, both in the number of present species, but also in the proportion of useful species of that figure. They were very similar, and well, the idea is that the 3 different patches are complementary sources of plant resources for local people, for many different uses that make subsistence a diversified strategy. And this is also combined with the cultivation of home gardens. This is probably the best representation of a Maya home garden, which we have been recording more than 300 useful species in this type of agroforestry system, both cultivated and wild plants, which are more important in this part of the home garden. So the home gardens are also very important reservoirs of wild plants. So not only have a strong meaning for subsistence, but also for plant conservation. So what do the cultivators Maya, how the Maya cultivators make decisions for managing their resources? Well, it depends on the species, it depends on the use of that particular plant. So they may decide to, to harvest their plants in home gardens when they are edible plants, probably firewood, but medicines, fodder, and wood for making utensils, they come from mostly secondary forests and other types of patches. In the past, in the pre-classic, there was supposed to be a trading system, very important, between the highlands and the lowlands. Well, in plant resources such as Sabal Yapa, and probably Sabal Mexicana, were very important in that trading system, as it happens still the present. We did population estimations of how sustainable this practice is, and we found that it's really sustainable under the dynamics of shifting agriculture. So in conclusion, this, we cannot speak just of Sweden agriculture, shifting agriculture, but this is a part of a complex system that we suppose it was inherited from the ancient Maya. Thank you very much.
Muchas gracias a los panelistas por sus muy interesantes presentaciones. Ahora yo voy a hacer unas preguntas y voy a pedirle a cada uno de ustedes que la conteste en 5 minutos. ¿Qué pasó? I'm sorry. Absolutely. I am going to first thank you to the panelists for their excellent presentations, and I'm going to ask questions to each one of them. I'm going to ask them to stick to 5 minutes to their answers. I'm going to ask first to Gerald. Is pollen a good proxy for the natural environment? We see that many of the species are tolerated or promoted. When you look at the pollen profile, are you really seeing the natural environment?
Yes. I get paid for it. No. No, seriously. No, I think pollen is a very good indicator, and it's not just here in the peninsula. It's globally used for climate, understanding past climate change and environmental change. But obviously it has its limits or its possibilities, which are not infinite. So we have to, like in other areas of science, you need a clear question, what do you want to answer? For example, in the long course, on the long 7,000 years course, high resolution, it's high resolution every 50 years. We can get probably down to 25 years. But then it's over because characteristics of sedimentation and other errors of age control we would include. So, but 25 between 25 years and 50 years of time resolution for the last 7,000 years, gives us a clear picture what were the main climatic drivers changing the forest. If we look on the smaller scale, like the colleagues presented, in a yearly scale, it's not possible. So it's important to have the mind clear what each proxy or like pollen can tell us. And about Brosimum.
Yeah,
yeah.
Tell us about Brosimum.
Yeah, and Brosimum, like Anabel said, it was a very important tree species for the Maya people. It's wind pollinated, and we saw this graph which Anabel presented. Personally, we work not with one single species. We work with a group of species to avoid bias given by the own species, that it won't reflect well climatic conditions. Anyway, in the group we use, like tropical forest, Brosimum is included, but not like one species, but like a group of indicator species for specific climatic conditions, and specifically precipitation levels and temperature adjustments. So in my view, not only in the tropics, but also in boreal palynology, vegetation reconstruction should not be based on one taxa, on one specific species. It should be a group of species which strengthens your interpretation. So, hope it's clear.
Okay, thank you very much. Anabel, I have two questions for you. What role does climate change play in Maya agroforestry management, and specifically in the so-called collapse? Maybe you can elaborate a little bit on the appropriateness of that word.
Yeah, I definitely don't like the word collapse. I think it implies that there was an abandonment, and I really do not believe there was any population reduction at all. I think the population of farmers stayed, and what really happened, I'm starting backwards, I guess, that only thing we know as archaeologists is they stopped or they started to neglect the centers, and that ultimately they were left to their own device. Think of Detroit, and think of how it doesn't take much where you stop, where the collective decides it's not worth supporting the infrastructure, and I think that's really what's happening. I mean, I've given lectures in places in Mesoamerica where when I walked into a big the place where I was going to give the talk, it was raining and they had buckets holding for grabbing the water, so you didn't slip. But the fact is they weren't repairing the roof. And it doesn't take long for infrastructure of a room like this, if you're not maintaining the roof, for it to fall down. So I think that our prejudice is really for the collapses. They stop maintaining big infrastructure. Now, the other question was management. I think that the entire picture of the Maya civilization and how they were using the landscape was managing under conditions of annual drought, of different kinds of climatic stresses that were longer term, that evolved after 4,000. We didn't have any settlements before 4,000 years ago, and it's after that we start seeing settlement. And I think that was an adaptation to climate change. And I think the collapse is really an adaptation to too much political intervention rather than climate change. I don't think that the data are forthcoming enough for me to feel that climate was a factor in the collapse.
Do you think that the Maya today manage their forests and practice agriculture the same way as their ancestors 1,000
well, same.
or?
I think you can't say same because, of course, it's a global, or weren't you telling me it's global already? I mean, they certainly didn't have the Chinese influence of citrus or the Mangos or banana or sugarcane. But in essence, I think we're looking at a heritage of management that is really embedded in the language of the Maya forest, something I really worry about, because even people who aren't speaking the language talk about the forest in a very conservative way. If you walk with them, they're always talking about taking care of the mariposa that is in the tree that needs to be taken away. There's a strong sense of taking care of the landscape, and I think it's really important to consider that that's a vital part of their life. So I think it's a real clue to how the landscape looks. They have a very dispersed settlement pattern in ancient Maya times, and if you look at the contemporary Maya, even the ordenanzas were saying, right at the time of contact, we're saying, no monte in the villages, no milpa in the village, and if we see them, they will be burned. That means that there was monte, the one you're talking about, the vital seed bank, and there was maize, except they couldn't see the polyculture that was going on there. They used what I call ecological imperialism. And in fact, I'm sorry to mention this, but arable is one of my favorite stories. Does anyone know what arable means? Can anyone tell me what arable means? Yes? No, arable means plowable, and the Maya did not plow. Remember my first slide I tried to get to early on. They came with the use of fire and stone. If we look for arable land, we're not looking for cultivable land. E.O. Wilson references arable like 400 times in his Future of Life on this planet, and we should be looking for cultivable land. And if back to the past in the future, I think the Maya forest garden is a possibility for saving the Maya forest.
Okay, thank you very much. David, I have a question for you. Do you think that the social complexity of the Maya, what you see in the evidence that you work with, was linked to the agricultural intensification during the classic period? Is there evidence of agricultural intensification?
Oh yeah, there's lots of evidence of agricultural intensification. First of all, I want to point out that the ancient Maya, especially the classic period Maya, were a very complex civilization. They built 50-meter temples, they had calendrics, they studied astronomy, they built large stelae with glyphs on them. They did many things very differently than they do today. So while it's very important to look at how the modern Maya practice their agriculture, we have to be open to the possibility that the ancient Maya, just as they were far more complex in their many other aspects of their way of life, they also were more complex in their agricultural activities. Now, I mentioned a number of possibilities. They built terraces, which are wonderful innovations, especially when there's a little bit of topography, that it can deepen the soil, it retains moisture, and it really helps plants grow much more efficiently. Also, they would build canals, they did raised fields, they had drain fields. And importantly, at Tikal, I was talking about a system of irrigation, where it was a system where they had built a reservoir and they used the reservoir to irrigate the fields below the reservoir. This doesn't happen anymore. And was this controlled from the top? I think it was, because the reservoir at Perdido, it drained out of the Mundo Perdido, which is an important plaza in the site core of Tikal. And this only could have happened with the permission and I think with the direction of the elites at the top. So the elites directed this irrigation system. And it must have been a very powerful thing for the Maya of Tikal, because suddenly they had some control over the water. They didn't have to just rely on rainfall. They could direct the rainfall that came down into the plaza, into the reservoir, and then they could water plants as they needed to. So yes, it was agriculture among the ancient Maya was much more complex, and they had developed many different kinds of agriculture that we just don't see today.
That kind of water management systems has been documented in other cities as well, or just Tikal?
Well, the reservoir system has only been documented at Tikal, But the terraces, for example, were, through the addition of LIDAR, we're now finding that terraces are much more common in the Maya area than we once believed. That Caracol, for example, they didn't know it, but now there are terraces all over the place. And they can see this through LIDAR. And this is a technique where you can see the shape of the land through the trees. It's almost magical. There are other sites, the Chan site, where they found lots of terraces there. So this is a technique that is becoming more common. At Tikal, we found terraces, and we've just received the LIDAR images there. And I think after the LIDAR images have been analyzed, we're going to see that there were a lot more terraces at Tikal. So a lot of these innovations were widespread.
Okay, thank you very much. Javier, last but not least, what would you say is the influence of contemporary Maya home gardens on the nature of the Maya forests today? And I should have also asked to any of you, do we see signature from the past today, from the past management today? But my question to you right now would be today.
Well, I would say that home gardens, besides providing products for the family subsistence, is an important...
Usa el otro. Ese no está encendido.
Oh, yeah. Yeah, I was saying that besides seeing the home garden as a source of products for daily subsistence, we can also see this agroforestry system as a refuge for wild plants from the forest, mainly in those areas where the forest has become too far. When the Maya people cannot walk long distance to get some medicine, some firewood, that's when the home garden becomes very important. So that's why many people try to maintain in their home gardens wild species to have them on hand. More, I wouldn't say that the home garden has an effect on wild vegetation, except for those cases of plants that are under domestication. Some authors have said that those are the places where people carry out plant selection for getting better products. And we can think of the Chaya, we can think of even Ramon, where people are selecting the desired phenotypes. But that doesn't mean that those particular plant species come back to the forest. The situation is that you cannot have every species in your home garden. So you need to go to the forest to get the products you need. When you do the milpa, you left trees from different species, trees and shrubs of different species to stand. So that assures you that you will have the products you need in the near future. So it's a way of modeling the forest that people need for subsistence.
But clearly, then you are changing the structure of the forest, I mean the composition of the forest.
Yes, they change composition, they change forest structure. You can think of Sabal, for example. You can see differences in plant size in the population, in the plant size structure in the population of these palms that is a result of management. So they model the forest not only in composition, but also for some particular species in structure of the community.
Just to finish the last question I have here for you guys. Clearly, we see and we think about these systems in a way that is, there are filters in our minds and in our words. When we use words like collapse or slash and burn and things like that, we are filtering and imposing certain views of the world on other world's views of the world. So just to finalize, give me an idea of why we should, how we should look at these systems that are so old and so so rich and diverse today, when we are also going through a phase of fast change and in all kinds of senses, and what these systems and what these societies can teach us today that is valuable for industrial societies, not just for description, as a description of something pretty interesting and fantastic, and is our history and our inheritance, and we should cherish it because of that. Well, this is for all of you.
I think the ancient practices that we see still today in the field are a basis for designing better strategies for plant management, for obtaining not only products for daily subsistence, but also for the market, for the green markets, for example, that could improve people's living conditions. At the same time, conserving the forest for the future generations.
Any of you would like to? Anabel.
I think that a colleague of mine, Scott Feddick, has put together 500 indigenous Maya forest plants that have Maya terms and are used for food. And I think people are always worried about food, and if we let that knowledge pass and we don't know how to make our own foraging, right here in the Yucatan we could be eating 500 different things on our plate that comes from the forest. I think we don't want to reinvent that. It would be nice to know that and start using them, chaya included.
I certainly think that we have many things to learn from the ancient Maya. I think their agricultural intensification has many applications for today. I think terracing, which is very little used in Central America, could enhance the productivity of lots of areas in this region, so we can look to the past to learn about the future. I think also there's a lesson that we can learn from the Maya, that we need to be careful about our interaction with the environment, because things can happen that if we neglect the warning signs, that bad things could happen to us as well.
Yeah, I think ancient Maya culture is a perfect example of a culture with very high knowledge and cultural advances, but something happened. So it should be like a message to us, like the colleagues already said, to take the knowledge which is already available and trying that this knowledge is not lost, and because the environmental degradation we are seeing in the Maya forest, it's not coming now from climate change right now. It's from bad management or inappropriate land use. So in the next couple of decades we will have the effects of climate change, but now not in a very strong way yet. So I think we should preserve this ancient knowledge.
I would like to keep asking you questions, but I'm going to open the floor to the public. We have 15 minutes for questions from the floor, and I would appreciate the help of anybody that can circulate the microphones. There is a hand over there. Please suggest who would you like to have an answer from?
Well, picking a person will be tough, so I'll just put that to the panel. I was greatly influenced by the reading of books from Diamond about his way to summarize and to reduce to a certain number of drivers what happens to human societies, and I'm curious to find what would be your main criticisms to his framework for understanding the demise of civilizations in different places, taking as an example the Maya.
I don't think that I'm the only one that feels that the Diamond treatment of the Maya is not very faithful, but I know people who have looked at his collapse volume and looking at every example, and everyone who worked more closely with those data don't find that he has treated the data in a very comprehensive way. His points, though, which are 5 points, I can't remember, gated communities and environment, all those points are really serious points, and they're things that we should take to heart. But the way he treated the secondary data without inquiring or creating a new narrative is a problem. His narrative of environmental collapse with the Maya I don't find as a done deal. I mean, yes, the preponderance of people believe the Maya destroyed the environment, but I think that's a hypothesis that needs to be tested, and the work that I'm doing suggests an alternative. So I don't like his summary.
In many ways, I would agree with Anabel on this account. I don't think the Maya destroyed their environment. I don't think the late classic Maya destroyed their forests. I think that what I have seen is they learned from a lot of mistakes that they made during the pre-classic period. They had a lot of problems with erosion. They learned to fix that problem, and then they went on to develop a much more complex and a much more elaborate society. And things did happen. I would say that they did reach a tipping point, and they went beyond the ability of their environment to sustain a large population. That part, I believe, is true, but I don't think environmental degradation was the cause of the Maya collapse.
Another?
So I was just wondering, there are a number of different Maya groups that still live to this day throughout the Yucatan, Quintana Roo, Chiapas, in Belize, Guatemala. So there has been a lot of adaptation to local conditions, and their management has changed and it has diverged to a great degree over these areas. So I was just wondering, first, whether we think that the modern Maya agroforestry systems are good analogs for historical Maya agroforestry systems, that's one. And then two, which one do we think is the right analog?
I think it's not possible to say that there is the right one. No, they are different. I think we have to think of the Maya not as something static, neither the ancient, neither the modern Maya. They are always adapting to changing ecological, political, social scenarios. If you travel through the peninsula, northern peninsula, you will see some areas with forest, but you will see also areas deforested. And that's a result, the last situation is mainly a result of economic activities that are recent from the 19th century. But what the Maya people did after liberating from slavery, vinculated to growing sisal, was to create new strategies for subsistence. So nothing is static. They are all the time adapting. And that, I think that's also the situation for the ancient Maya. We could think that they faced different situations, and maybe we cannot think of a collapse, but maybe just migration and adapting techniques to new areas they found. I don't know, it's always is change.
I would like to say, just in addition to that, that it's important to remember that people talk about the Maya collapse, and many people object to that. And the reality is that the Maya are still with us. They are a vibrant culture, and they have continued to change in many ways. And so we're grateful to them for that. But when people talk about the collapse, really what happened there was it was the collapse of the late classic socioeconomic political system of the Maya, and it occurred mostly in the interior elevated region. That's sort of the plateau that went from just north of Lake Petanitza up into the Buk region. And these areas were areas that didn't have any reservoirs, they didn't have any permanent water source, they didn't have any lake, they had reservoirs, but they were empty. But they didn't have any permanent water sources, and this really led to their demise.
I like the idea that it's the Milpa cycle is a very flexible one. And I remarked that I was reading a book by James Scott. I don't know if any of you have read him. It's called Seeing Like a State, and then The Art of Not Being Governed. And the art of not being governed, when manioc and maize was introduced to Southeast Asia, all of a sudden, all these people who were living in sort of captive paddy rice systems fled to the hills and used maize and manioc. And in fact, it was a very successful escape agriculture. So to say how flexible it is, temperature, time it needs to mature, elevation, it's really a flexible system. So I think that was what the Maya were really skilled at.
I would like to have more questions from the public, but I'm being told that time is getting over, and I would like to repeat the same questions that we asked at the beginning now and see if maybe your answers would be affected by the panelists in some way. If there are interesting results, the purpose of the organizers is, they have been doing this in other panels, and maybe they are going to like to write something about the results in case you don't have any objections to doing that. So let's do the questions again, please, and see whether they change or they don't change. Ten more seconds. Okay, that's it. Next question, please. Here's the question. Wow, this has been very dynamic. Okay, 10 more seconds. Done. Can you stop it? Bueno, muchísimas gracias a todos. Again in Spanish, right? Thank you very much to all of you for your presence. Thank you very much to our panel. Please join me in thanking them for their work. They have answers. They have already an analysis. They already did an ANOVA, a t-test of the results. Well, it's going to be a chi-square. ¿Ya lo tienes? Gracias. ¿De veras ya tienen resultados? ¿Y ya hiciste la G cuadrada? Tiene que ser una G cuadrada, si no, no, No chi-square, so 101, that's nice. Very interesting. The panel did not affect your brains at all. Bueno, pues muchísimas gracias.